Okay, so here is my Unit 1 project. Um, yeah, so here's our problem. First, always read the problem. A rectangle's personality is a combination of its length and width. A rectangle with an area of 18 might have either of these personalities. Which rectangle with uh, which rectangle that is less than 1,000 has the most number of unique personalities? So what I try and find is, what is this problem asking? And to me, it looks like this problem is asking how many different factors that are separate are what number has the most factors that is under 1,000. So yeah, so for how can we find this? And knowing that 1,000 is a very big number and that would be 1,000 numbers we'd have to go through, we know it's just way too much to solve for how many factors each number between 1 and 1,000 has. So we should start on a smaller scale. Okay, so first I did under 10. Um, 4 had one of the most, 6 had, but yeah. So from there we just kept going and we went to 25. And we started to notice these numbers that were bigger than the rest, like 16, 18, 20, 24. These are more composite. They have more factors. That's what we're looking for. So I kept with it. I multiplied these numbers to try to get them to be as close to 100 as possible. And then from there, I added a 0 to them. So 60 became 600, 72 became 720, and so on. From there, I found how many factors each of these had. So 600 had 24, 720 had 30, 840 had 32, 900 had 28, 960 had 28. Okay, so we know, and also there's 32 factors, but that means that there's actually 16 pairs of factors between them, which must be noted. Okay, so we know that 840 is the biggest, and I checked my answer and it was correct. So then, how can we make this problem harder? At first, I was kind of stumped, like this problem seemed somewhat one-dimensional. And then I thought of prime factors. So we know prime numbers, of course, and yeah, so the prime factors would be what prime numbers times each other would make, or would the most of those be needed? So the most unique personalities for a number under 1,000. Um, so I started doing this, and I realized how like 1 times 2 times 3 times 5 times 7 would give you 210. And then if you were to add any other number to the end of it, it would go over 1,000. And this would work with even if you changed out for all the different numbers. So I knew that this would not be good. I asked Jonah, should I just give up on this problem and start another one? And he gave me the advice to use 100,000 instead of just 1,000. Because, yeah, to make it even way more grand than it was, because it seemed a little simple. So then I did that. The most factors under 100,000. So first I just used the smallest factors I could find, which were 1 times 2 times 3 times 5 times 7 times 11 times 13. This gave me 30,030. Uh, if I was to multiply this by the next prime number, which would be 17, it would go over 100,000. So I knew that that wouldn't work. And then I thought to myself, what if I try switching out numbers? So first, I switched out the 13 and made it a 17. This gave me a bigger number. So then I decided and after consulting with Jonah, that I need to change the wording of my problem. So I changed it to, if numbers are tied for the number of factors, which number would be the smallest? So the answer was the first number I got, which was 30,030. Thank you so much for listening to my project, and thank you, Jonah Backler, for your advice and feedback.